Hi students, this is Alex here. In this video, we are going to find the half-range Fourier sine series for the given function f of x. The expansion formula is f of x equal to summation n equal to 1 to infinity bn sin n pi x by L, but here L is 2, so we get sin n pi x by 2, and bn formula is 2 by L integral 0 to L f of x into sin n pi x by L dx. We are going to substitute 2 for L, so 2 by 2 integral 0 to 2 f of x into sin n pi x by 2 dx. So after cancelling this, we get bn. We are going to evaluate this bn, but the function is made up of two parts. One is x and 2 minus x for interval 0 to 1 and interval 1 to 2. So we are going to write bn equal to, we take the first interval 0 to 1. F of x is x here, and we have sin n pi x by 2 dx. And second part is from 1 to 2, and this time our function is from 2 minus x. From the interval 1 to 2, function is 2 minus x into sin n pi x by 2 dx. Now we are going to use Bernoulli's formula. First part, this is u and this is v. So u equal to x and v equal to sin n pi x by 2. So differentiation of u is 1. Next differentiation is 0. Similarly, integration of v, which is v1 minus cos n pi x by 2 by n pi by 2, and v2 will be minus sin n pi x by 2 by n pi by 2 whole square. In the same way, we are going to take this as u and this as v. So u equal to 2 minus x and v equal to sin n pi x by 2. U dash is minus 1, u double dash will be 0, and v1 will be minus cos n pi x by 2 by n pi by 2, and v2 will be minus sin n pi x by 2 by n pi by 2 whole square. And Bernoulli's formula is uv1 minus u dash v2 plus u double dash v3 dot dot dot. Now coming to bn, u which is x, v1 is minus cos n pi x by 2 by n pi by 2, minus u dash is 1, and v2 is minus sin n pi x by 2 by n pi by 2 whole square. Coming to the second part, we have 2 minus x into minus cos n pi x by n pi x by 2 by n pi by 2. Then u dash is minus 1, so we put plus 1 here because already there is a minus u dash, and minus sin n pi x by 2 whole divided by n pi by 2 whole square. And we have 0 to 1 as the limit for the first one and 1 to 2 as the limit for the second one. So we completed the integration and we are going to apply the limit. When I apply the upper limit 1, this becomes 1 into minus cos n pi by 2 by n pi by 2. And we can make this as plus. When I put the 1, we get sin n pi by 2 by n pi by 2 whole square. When I put the lower limit, because of this x it is 0, because of the sin it is 0. So totally the value of the lower limit is 0 for the first set of terms. Now coming to the second set of terms, we have to apply 2. So 2 minus 2 is 0. So first term is 0. Then when I put 2 here, we get sin n pi. So that is also 0. Then we have only lower limit. When I put 1 here, 2 minus 1 is 1. When I put 1 here, minus cos n pi by 2 by n pi by 2. When I put 1 here, it is minus sine n pi by 2 by n pi by 2 whole square. And we completed the limit substitution. Now Bn will be, first term is minus cos n pi by 2 by n pi by 2. Second term is sin n pi by 2 by n pi by 2 whole square. Third term, we have to take this minus inside. It will become plus cos n pi by 2 by n pi by 2. Then if I take this minus sign here, it will become plus sin n pi by 2 by n pi by 2 whole square. Then after this, we can cancel these two terms because they are same term with opposite signs. Now these two terms are similar terms, so we can add it as 2 times of sin n pi by 2 whole division. This is n square pi square by 4. The by 4 I can take it to the numerator. So finally we got Bn, which is 8 sin n pi by 2 by n square pi square. So we got Bn. Now coming to the expansion formula, f of x is equal to, we have to take summation n is equal to 1 to infinity Bn. For Bn, it is 8 sin n pi by 2 by n square pi square into sin n pi x by 2. So this constants can be taken outside. So 8 by pi square summation n is equal to 1 to infinity. We have sin n pi by 2 by n square into sin n pi x by 2. So this is our required half range Fourier sine series expansion for the given function f of x.